Hello everyone. So today I'm going to be talking about Statistical Process Control, or SPC. So what is SPC and why is it important in engineering or just data analysis in general? Statistical Process Control is a scientific visual method used to monitor, control, and improve processes by eliminating special cause variation from manufacturing, service, and financial processes. Or more simply put, SPC is not a formula but rather a tool to help identify problems. So what do I mean by a tool? Well, the best way to explain it is to give you some examples, such as the histogram, the fishbone chart, and the control chart, with the control chart being among the most common and useful. The control chart is special because it is a graph that shows how a process changes over time. Using previous data, upper and lower control limits are determined and set, and a mean line is placed in between the control limits. When new data is plotted on the chart, we can draw conclusions based on where the data falls. If a data point is plotted between the lines, it is deemed acceptable and the process continues, but if a data point falls outside the control limits, it is considered an outlier and needs to be further examined. It's important to notice that the tools were all ways to help us visualize data so we can draw conclusions from them. That's why SPC is so powerful and is widely used. By visualizing data, we can quickly identify outliers and determine if our process is running as it is designed to. Another reason why SPC is so useful is because it is cyclical. Samples are taken during the process and then plotted in a control chart, for example. If the engineers are content with the data, the process will continue. If they aren't, then the process is stopped, adjusted, and then ran again until the engineers are satisfied. So why is SPC important in the aerospace industry? The main reason is quality control. Flight, and specifically spaceflight, heavily depend on the parts that they are made of. If a jet turbine blade breaks due to wear, it puts the flight and its passengers at risk. During the shuttle era at NASA, a report was written detailing how SPC was used to calibrate all of the machinery used to produce the shuttle parts. The NASA Measurement Standards and Calibration Lab was responsible for managing all NASA and contracted equipment to make sure that the machines were working properly. Two types of control charts were used, the P chart and the U chart, to accomplish this goal. In the end, it was found that the U chart was superior because it was based on a Poisson distribution and was able to plot the fraction of defective per unit rather than the proportion of defective units. This allowed NASA to identify which machines were functioning properly and ensured the safety of the space shuttle.